My name is Tyler. I'm here to give you guys a crash course through Brouwer's fixed point theorem. It's actually quite a complex theorem, and it's used in a lot of principles that a lot of people don't even realize where math is used. Some of those more obvious places would be Euclidean space. It's a study of three-dimensional geometry. But then you run into things like differential equations and chaos theory. This is where you get into weather prediction. Then you also have the population studies, animals as well as people. So it's used in many, many fields. It applies way across the board. Some of those, the places that I found were from Brouwer's translation theorem for three homeomorphisms. It's a study of fixed points, and it's a documentary that was done on his studies. What we're going to use is called the intermediate value theorem to progress through. But first, let's talk about what a fixed point is. A fixed point is also known as an invariant point. What that means is that whenever you plug it into the function, whatever function it is, what you'll get out of it is what you put in. So what happens is you just repeat the process and you get back the same answer. So here we have what it would look like if your whole function was that. It would just be the graph of y equals x, where it's the same thing all the way through. The intermediate value theorem. So if we assume, let's let f be continuous, f is our function, we'll let f be continuous on a closed interval ab. Let n be any number between f of a and f of b, where we have, what happens here is we put in a and we get f of a. We plug in b and we get f of b. Now these can be switched, they don't have to be in these locations. And we're going to assume that n is any number between these, and what that means is that c will fall between a and b. There will be a value c that lies between them. So n equals f of c. Now what happens with Brouwer's fixed point theorem is for any continuous function f of x with a domain of 0, 1 and range a subset of 0, 1. So what happens is between these 2 points, 0 and 1, and it comes out, everything between there falls between 0 and 1 on the y-axis, then there will be a fixed point somewhere in here. The fixed point implies that f of x equals x. And this is the definition of a fixed point. So what we're going to do is we're going to use some basic algebra. Hopefully everyone understands what happened. We move the x over, so we get f of x minus x equals 0. This is basic algebra. So we're going to create a new function out of this and set it to g of x, where g of x equals f of x minus x. With that function, if we plug in 0 for g of x, then we get f of 0 minus 0. If it comes out to 0, we have a fixed point, because that's what this is saying. If we plug in 1, and we get 1, f of 1 minus 1 comes out to 0, we have a fixed point. However, that's not always the case, and it gets a little more complicated after that. So now we apply the intermediate value theorem. So now we get to use the intermediate value theorem. And what that says is that if we plug in 0, and f of 0 is going to be larger than 0. So it'll be something that we plugged in, and it's going to come out with an answer above that. So our answer is going to be greater than 0, which is something greater than 0. It doesn't have to be 1, it just has to be higher than 0. So if we plug in 1, and we subtract 1 from it, because this will give us an answer that's smaller than 1, because we're staying within our subset of 0 and 1. So what happens is we subtract the 1 from it, it's going to come out with something negative, something less than 0. So that'll be down here. Now the intermediate value theorem, in layman's terms, says that between these 2 points, it's going to cross this x-axis here. And when it does, f of x minus x will be equal to 0. So so we'll set in to our x-axis here, where g of c equals f of c minus c. So wherever it crosses here, that's going to be the point at which we have our fixed point. And that is basically the intermediate value theorem in practice with Brouwer's fixed point theorem. And it's really neat, and it's something that is looked into. It's used so far across the board. It's even applied in gaming graphics and all kinds of things of that sort. And hopefully some of you can at least find it semi-interesting. Thank you. Well, you know, if anybody needs a tutor, I do that too.
Yeah, he does.